Miss Mega.
Hello friends, this is Unit 6 software testing. Here is the web app testing. In this web app testing, the content model for the web app are contents are evaluated syntactically and semantically. Syntactic errors like spellings, grammar, etc. are assessed. Semantic errors, correctness, consistency, and ambiguity are assessed. The interface model is reviewed to ensure that all use cases can be accommodated. The design model for the web app is reviewed to uncover navigation errors. The user interface. It is tested to uncover errors in presentation and or navigation mechanics. Each functional component is unit tested. This is the web app testing second, in that navigation throughout the architecture is tested. The web app is implemented in a variety of different environmental configuration and is tested for compatibility with each configuration. Security tests are conducted in an attempt to exploit vulnerabilities in the web app or within its environment. Performance tests are conducted. The web app is tested by a controlled and monitored population of end users. The result of their interaction with the system are evaluated for content and navigation errors, usability concerns, compatibility concerns, and web app reliability and performance. High order testing, validation testing focus is on software requirements. System testing focus is on system integration. Alpha or beta testing focus is on customer usage. Recovery testing forces the software to fail in a variety of ways and verifies that recovery is properly performed. Security testing verifies that protection mechanism built into a system will in fact protect it from improper penetration. Stress testing executes a system in a manner that demands resources in abnormal quantity, frequency, or volume. Performance testing tests the runtime performance of software within the context of an integrated system. This is the debugging, a diagnostic process. Art of debugging. Debugging is a process of removal of a defect. It occurs as a consequence of successful testing. Debugging process. Test cases are executed. Actual results are compared with expected results. Find the lack of correspondence between actual and expected results. The suspected causes are identified and additional tests or regression tests are performed to make the system work as per the requirement. Here is the debugging process in which test cases. Here, debugging is identified causes, then corrections, then regression test cases, and finally go to the result. Here are the additional tests and suspected causes. Debugging approaches, that means debugging techniques, brute force method. Let computer find the error approach is used. Memory dumps and runtime traces are examined. Program with a right statement is loaded to obtain clues to errors. Backtracking method. The source code is examined by looking backwards from symptom to potential causes of errors. Cause elimination method. Binary partitioning method is used to reduce number of locations where errors can exist. These are the testing versus debugging. In the testing process in which the bug is identified, and is in debugging process in which bug or error is corrected by the programmer. In testing, it is identified where the bug occurs, and in debugging, the root cause of error is identified. In testing, it starts with the execution of test cases, and debugging starts after the testing process. Here are the debugging efforts. Time required to correct the error and conduct a regression test. Time required to diagnose the symptom and determine the cause. Here are the symptoms and causes. Symptom may disappear when another problem is fixed. Cause may be due to a combination of non-errors. Cause may be due to a system or compiler error. Cause may be due to assumption that everyone believes, and symptom may be intermittent. These are the consequences of bugs, where bug type and damage: mild, annoying, disturbing, serious, extreme, catastrophic, infectious. Here, the correcting the error is the cause of the bug reproduced in another part of the program. In many situations, a program defect is caused by an erroneous pattern of logic that may be reproduced elsewhere. What next bug might be introduced by the fix I am about to make? Before the correction is made, the source code should be evaluated to access coupling of logic and data structures. What could we have done to prevent this bug in the first place? This question is the first step toward establishing a statistical software quality assurance approach. If you correct the process as well as the product, the bug will be removed from the correct program and may be eliminated from all future programs. These are the final thoughts. Think before you act to correct. Use tools to gain additional insights. If you are at an impasse, get help from someone else. Once you correct the bug, use regression testing to uncover any slight effects. Thanks for watching the video.